Hello guys, and welcome to the next unit for the IPC Flipped Classroom. Once again, I'm Mr. Hawkins. Today we're going to be dealing with the beginnings of solutions, okay? This is a big unit, covers all kinds of different stuff, but first of all we need to start with the first thing. The most important thing here is water, alright? Water, water everywhere and not a drop to drink, alright? So, water. Okay, water is known as the universal solvent. Okay, it's known as the universal solvent because more substances dissolve in water than any other solvent in the world. Okay, now there were two vocabulary words that we looked up in class. Okay, solvent and solute. Okay, you remember the solute is what goes into the solvent, and the solvent is the stuff that it's mainly composed of. Okay, now that means that the majority of things, okay, dissolve in water. There are more things that dissolve in water than there aren't things that dissolve in water. Okay, does that make sense? So water is the universal solvent. Everything's going to dissolve in it. Okay, but why? Why is that important? Okay, and water is such a good solvent because it is polar. Okay, this is a vocabulary word, one that we probably looked up. But if not, a polar molecule is a substance that has an uneven distribution of its electrons. All right, remember that electrons had a negative charge. Okay, so if it has an uneven distribution of negative charge, then that means that one side's a little more negative than the other side is. Okay, so look at this water molecule here on the right. Remember that the formula for water is H2O, okay? As you can see, we have our two hydrogen molecules and our two hydrogen atoms and our one oxygen atom, all right? And as you can see, they're covalently bound. They're sharing their electrons to get a full valent shell. They're getting the full octet, all right? But as you can see, in the waters, do you see any extra electrons on the outer rims of it? No, okay? They're all located towards the oxygen. That's where the electrons are. So that leaves that back end bare and thus becomes positive, okay? It has a positive end because that's where essentially the nucleus is hanging out over there, and it has that positive charge. Remember, the nucleus has the protons, and so it has a positive charge. Now, for the oxygen, okay, it has tons more electrons hanging out on the back end of it as compared to the hydrogen, okay? The hydrogen has a lot less. So having those electrons located over there gives it a partial negative charge, all right? So thus we have poles on our water molecule. Partial positive sides and partial negative sides. Much like the Earth has a north and south pole, okay? We have positive poles and negative poles in polar molecules. Now, being a polar molecule, water has some unique abilities, and one of them is hydrogen bonding, all right? Now, what is a hydrogen bond? We've talked about ionic bonds, which were between metals and nonmetals, and they were due to charge, okay? We talked about covalent bonds, which is because they just want to have a full shell, so they share them. Now we're talking about hydrogen bonds. This is the third different type of bonding, all right? Hydrogen bonds occur. They're not necessarily an actual bond, okay? They're a attraction between positive and negatively charged polar molecules, okay? That partial interaction allows them to sort of bond together, okay? Now, having that charge-based bond kind of makes you want to think that it's ionic, but in this case it's not, all right? It's only a partial charge. Those hydrogen bonds are not strong, all right? Salt is super strong. If you hit salt with a hammer, it might break a little bit, but you're still going to have salt at the end, okay? Now, if you break a hydrogen bond, you're just going to split it back, and they can reform real easy too, okay? Have you ever dropped a rock in a pond and noticed the waves start going, but after a while the waves kind of calm down, okay? That's because hydrogen bonding's once again recurred and made the surface level again, okay? That interaction between the water molecules from the negative end of the oxygen and the positive end of the hydrogen has created this sort of lattice, as you can see over here on the right, okay? All those little dots indicate a hydrogen bond, okay? If you ever see a dotted line, that's a hydrogen bond. Now, hydrogen bonding allows water to do some cool stuff, and that is things like this, okay?
Oh yeah, we gotta practice the
one-step code.
Yep. Yeah. Amazing.
Alright, so let's kind of talk about that real quick, okay? Whenever this kid went and did his belly flop, okay, you heard a nice pop noise, okay? And that's because he was actually breaking the surface tension that occurs on the surface of this pool, all right? When he flops, bam, okay? It's going to come out with a pink belly, all right? That is because there's so much tension in that water that it took him with a lot of force to break through it, okay? Now, surface tension, again, is caused by hydrogen bonding. Don't forget that. Cohesion. Cohesion is where water will attach to water, all right? Water molecules like to get close to water molecules, and that's the reason that water beads up. It turns into those little ball-shaped things, okay? That is because of cohesion. It's sticky. It sticks to itself because of hydrogen bonding, all right? Now, surface tension is also something else that's a property of water, all right? Surface, the hydrogens and the oxygens in water form a surface layer, essentially a solid layer of water. Okay, it's not permanent because, as we said, those attractions are weak, so you can break them real easy. But if you have something that's real light, just light enough to not interfere with that attraction, it can actually float and walk on water. Okay, that's why you see this bug over here on the right. Those skimming bugs just skim across the surface of the water and they don't actually sink. Okay, because they are using the hydrogen bonding and surface tension of the water to scoot themselves along. All right. So capillary action is another property of water, okay? Capillary action is where, have you ever set your straw in a drink and noticed that the straw kind of gets more water in it than the drink might have? Or if you cover the top of it, you can actually pick the water up out of the straw, or pick the straw holding the water out of the container. Okay, that's due to something called capillary action. You can see the celery here on the right. Capillary action has brought the red dye from the water all the way up to the leaves of the celery. Okay, and another interesting property of water is something called differential density. That's the reason that ice will float on water, okay? In its liquid state, water has a density of 1, but in its solid state, it's slightly less, okay? And we know that less dense things float on more dense things, so that's why ice floats, okay? It is because of the hydrogen bonding, all right? The bonding between the hydrogen and water molecules occurs such that it creates a pocket, okay, where air can get in, and that lowers the density, okay? Decreases the density and allows the ice to actually float because of the hydrogen bonding, all right? Remember, hydrogen bonding is the reason for all this stuff, okay? Hydrogen bonding holds a lot of us together. We're made up of 70% water, okay? So it holds us together, so to speak. It makes us work, okay? Now, hydrogen bonding occurs in all kinds of different things, and when you get into biology, you're going to learn much, much more about it. But for right now, understand that water, because it is polar in nature, participates in hydrogen bonding. And because it does that, we have things like cohesion and adhesion, which we're going to talk about in class. Surface tension, okay? Capillary action and differential density in the ice form, okay? So if you have any questions or anything like that, make sure you come in for activity period and ask them. If not, just don't sit in silence, okay? Come ask me, get your answer to your questions, post them in the comments section, tweet me, do what you need to do, okay? I'm here for you. You guys have a great evening.